Using the second derivative test, find any local extrema for the function f of x is equal to x times e to the x. The first step in this process is to find the first derivative, f prime of x. And because we have x being multiplied by e to the x, we need to use the product rule. And the product rule is first, which is x, times the derivative of the second, e to the x, plus the second, e to the x, times the derivative of the first, which is 1. Now you can also reverse these. You can do the second times the derivative of the first, plus first times derivative of the second, because addition is commutative. If we simplify this, notice we have an e to the x in both terms, so we can factor it out. So we have e to the x times x plus 1. And if we set this equal to 0, e to the x itself can never equal 0 because e is a constant value, and whether it's raised to the first power or the negative first power just moves it into the denominator, it can still be evaluated to be a number, and it can never be 0. So the only time that the derivative can equal 0 is when x is equal to negative 1. All right, now that we have our critical value, let's find the second derivative, or f double prime of x. And we can use the factored version of our function in order to make finding the second derivative a little bit easier. So we have, again, the product rule. One of the versions of it is first, which for us is e to the x, times the derivative of the second, x plus 1, and the derivative of that is 1, plus the second, which is x plus 1, times the derivative of the first, e to the x, which is e to the x. And from here, we can rewrite it as just e to the x plus e to the x times x plus 1. And now if we evaluate f double prime at negative 1, we will get e to the negative first plus e to the negative first power times negative 1 plus 1. So that's going to be 0 for this term, and 0 times anything is 0. So we have e to the negative 1, or 1 divided by e. And this is positive, so that means we have a concave up, so we have a local minimum at this value. So the local minimum at x equals negative 1, Roman numeral 2, or answer choice C.